How many subsets of A, that is a set of 1, 2, 3, up to 9 and 10 contain at least 3 of the elements of B, which is a set of the numbers 1, 2, 3, 4, and 5. Set A is equal to the set of the elements 1, 2, 3, 4, etc. up to 10. And set B is a set of 5 elements consisting of 1, 2, 3, 4, and 5. Let set C be the set of those elements that are present in A but not in B. Then set C is equal to 6, 7, 8, 9, 10. These five elements will constitute set C. Let set D be a subset of A that contains at least 3 elements of set B with any number of elements of C. That means set D will consist 3, 4, or 5 elements of set B with any number of elements of set A, which can be 0 or 1 or 3 or up to 10 number of elements of set A. Such a set D will be a valid set as regards this question. This question asks us to find how many subsets of A are there which contains at least 3 elements of B. Therefore, set D will be a valid set which will fulfill this criterion. For example, set D1 is equal to 1, 2, 3, and 6. It contains 3 elements from set B, those are 1, 2, 3, and 1 element from set 6. That will be 1 element of set D. Similarly, set D2 could be 1, 2, 3, 4, 5, 8, and 9. Here, the first 5 elements are from set B and the next 2 elements are from set A. So this is also a valid subset of for the question. So there could be many such sets D1, D2, D3, etc. and all of them will be valid subsets of A that we are looking for. Let's first find out in how many ways at least 3 elements can be chosen out of 5 elements that are present in set B. At least 3 elements means there could be 3 or 4 or 5 elements. The number of ways in which 3 elements can be chosen out of 5 when order is not important is the combination of 5 things when 3 are taken at one time. If order is important, then we will have to take permutation, but here order is not important, so it will be combination. That is, such a thing would be combination of 5 objects when 3 are taken at one time. So its formula is factorial 5 divided by, that is this 5, divided by factorial of 3 multiplied by factorial of the difference of 5 and 3. That is factorial of 5 divided by factorial of 3 multiplied by factorial of 2. Factorial of 5 is 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5. Factorial of 3 is this much, 1 multiplied by 2 multiplied by 3. And factorial of 2 is 1 multiplied by 2. So we have written down these numbers explicitly, and some of them will cancel out, giving us a result of 10. So 5C3 is 10. Or there are 10 ways in which we can select 3 objects out of 5. When you are selecting 4 elements out of 5, then the formula is 5C4. That is, 5C4 is equal to factorial of 5 divided by factorial of 4 multiplied by factorial of 5 minus 4. And this is factorial of 5 divided by factorial of 4 multiplied by factorial of 1. If we write that out explicitly, it will be 1, 2, 3, 4, 5 divided by 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 1. This last one representing factorial 1. And if you cancel out the common terms, we get the remaining figure as 5. So there are 5 ways when 4 objects can be taken out of 5. Similarly, for 5 elements out of 5, it is 5C5, and you can check yourself, it will become 1. Therefore, at least 3 elements out of 5 will cover all the above 3 cases, giving 10 plus 5 plus 1, that is 16 different ways. There are 10 different ways for 3 objects, 5 different ways for 4 objects, and 1 different way for 1 object to be selected out of 5 at one time. So the total of such things is 16. Let us call these subsets of B as set X. When we add 0, 1 or more elements from set C, that is from the set 5, 6, 7, 8 and 9 to set X, we get a valid subset of A insofar as this question is concerned. Let us now enumerate the number of ways in which we can select 0 or more elements out of the 5 elements in set C. We can select 0 element in 5C0 number of ways, that is 5 factorial divided by 0 factorial multiplied by 5 factorial. Remember that 0 factorial is equal to 1. If you do not know this, look into any textbook which deals with factorial. Similarly, we can select one element in 5C1 ways, that is 5 factorial divided by 1 factorial multiplied by 5 minus 1 factorial, and this will work out to 5. When you select 2 elements out of 5, that is 5C2, we get 5 factorial divided by 2 factorial multiplied by 3 factorial, which comes out to 10. And we have seen already 3 elements out of 5 gives us 10. 4 elements out of 5 gives us 5. And 5 elements out of 5 gives us only 1 way. So, the total number of ways in which 0 or more elements can be chosen from set C is the sum of all the above numbers, that is 1 plus 5 plus 10 plus 10 plus 5 plus 1, that is equal to 32. Let us call these subsets of Y as set Y. Remember that at least 3 elements can be chosen from set B in 16 different ways. So, the number of different ways in which at least 3 elements from set B can be combined with 0 or more elements from set C is equal to 16 multiplied by 32, which we just now found out, and that is 512. That is, in other words, 512 subsets of A can be made by combining one element of set X with one element of set Y. Therefore, the answer is 512. Thank you.